Hello everyone, welcome to today's C programming class. In today's session, we are going to learn one of the most important concept in C programming called formatted input and output functions. Whenever we write a C program, we need a way to communicate with the user. The program should be able to receive data from the user and also display the result on the screen. For this purpose, C provides different input and output functions. In C programming, input and output functions are divided into two categories. The first category is formatted input and output functions. The second category is unformatted input and output functions. Let's understand this with a real life example. Suppose you are filling an online application form. The form asks you to enter name, age, CGPA. Each field has a specific format. This is similar to formatted input because the computer already knows what type of data is expecting. Now think about chatting with your friend on WhatsApp. You can type anything. There is no fixed format. This is similar to unformatted input. So formatted functions expect data in a specific format. Unformatted functions simply read or display characters without worrying about the format. Here you can see two branches. One branch represents formatted functions, the other branch represents unformatted functions. Today class mainly focuses on formatted functions. C uses two functions for a formatted input and output. Formatted input reads formatted data from the keyboard. Formatted output writes a formatted data to the monitor. Now look carefully at this diagram. C programming provides several input and output functions. They are grouped into two sections. The first section is input functions. These functions receive data from the keyboard. Examples are scanf, getchar, getch, getc. Among these, today we are mainly study scanf because it is formatted input function. The second section is output functions. These functions display data on the monitor. Examples include printf, putchar, putc. Again, today focus is mainly on printf. Think of a teacher conducting attendance. The teacher asks the student's name. This is like input. Then the teacher announces the attendance. This is like output. Similarly, computer receives information using input functions and shows information using output functions. Now let us understand what exactly formatted input and output mean. Formatted input means reading data according to a specified format. For example, suppose we want the user to enter age as an integer, salary as a floating point number, grade as a character. The computer should know what type of value it is expecting. This is called formatted input. Formatted output means displaying data in a neat and organized format. For example, displaying salary with two decimal places. Display roll numbers in proper alignment. Displaying marks in a table. All these examples of formatted output. So formatted input is done using scanf. Formatted output is done using printf. Now let us study the printf function. Printf is one of the most commonly used functions in C programming. Purpose is to display information on the computer screen. The syntax is printf format specifiers variable list. Notice that printf requires two things. First, format specifiers. Second, variables. For example, suppose int age equal to 20. To print this value, we write printf %d within the double quotes, comma age. Here, %d is called the format specifier. Age is the variable. Think of format specifier as a label on a parcel. If the parcel contains clothes, the label says clothes. If it contains books, the label says books. Similarly, %d tells the computer this value is an integer. Without the correct label, the computer cannot display the data correctly. This slide is very important. Let us understand the structure of a format specifier. The structure is symbol followed by flags with precision, length, and finally specifier. Let us understand each part. First, flags. Flags control alignment. For example, left alignment or right alignment. Second, width. Width decides the minimum number of spaces reserved for the output. Third, precision. Precision controls the number of digits after the decimal point for floating numbers. Fourth, length modifier. It tells whether the value is int, long, or another larger data type. Finally, specifier tells the type of data. For example, percentage %d for integer, percentage %f for float, percentage %c for character, percentage %s for string. Think of booking a train sheet. First, you select the coach, then seat number, then class, finally passenger details. Similarly, a format specifier contains several pieces of information before displaying the value. First comes percentage, then flags, then width, then precision, then length modifier, finally the conversion characters such as D, F, C, or S. Now let us understand the first flag, the minus sign. The minus sign tells the computer to align the output towards the left. Without the minus sign, the value is aligned towards the right. Suppose we write printf percentage minus 10d comma 123. Here 10 means reserve 10 spaces. The number 123 will be printed at the left and the remaining spaces appear after it. Without the minus sign, 123 appear at the right and spaces appear before it. Think about writing your name inside a notebook box. If your teacher asks you to start from the left, you write from the beginning. If asked to write from the right, you leave spaces first and then write. The same concept is used here. This alignment becomes very useful when printing tables, student marks, employee salary reports, or any data where proper alignment makes the output easier to read. With specifies the minimum number of character spaces reserved for displaying the output. Look at the example printf percentage 5d comma 42. Here the number 5 indicates that the output should occupy at least 5 character positions. Since the value 42 contains only 2 digits, the compiler automatically adds 3 blank spaces before the number. So the output appears 3 blank spaces then 42. Now think of a parking lot. Suppose each parking space is designed for 5 meters. If a small car is only 2 meters long, the remaining space is still kept empty. Similarly, the computer reserves 5 spaces even though the number occupies only 2. Look at another example. Printf percentage minus 5d comma 42. If you wrote printf like this, the minus sign tells the computer to place the number on the left side, so the blank spaces appear after the number. This feature is very useful when displaying tables like student marks, employee salary reports, product list, where all values should appear neatly aligned. If you write printf percentage 5d comma 123456, will the computer cut the number? No, the computer prints the entire number because width specifies only the minimum space, not the maximum. Sometimes instead of blank spaces, we want the empty positions to be filled with zeros. For that, we place 0 before the width. Sometimes instead of blank spaces, we want the empty positions to be filled with zeros. For that, we place 0 before the width. See example printf percentage 05d comma 42. Here 5 means total width and 0 means fill empty positions with zeros. So the output becomes 00042. Instead of spaces, zeros are added. Let us compare this with a real life example. Suppose your college gives every student a roll number. Instead of writing 15, they write 00015. Why? Because all the roll numbers have the same number of digits. Similarly, banks, ATM cards, employee IDs, invoice numbers, passport numbers all use leading zeros to maintain fixed length. Now we come to another important concept called precision. Precision controls how accurately data is displayed. It behaves differently for different data types. Let us study one by one. See example printf percentage point 2f comma 3.14159. Point 2 means display two digits. Point 2 means display two digits after the decimal point. So the output becomes 3.14. The remaining digits are removed after rounding. In second example, printf percentage point 4d comma 42. Precision tells the compiler to print at least 4 digits. Since 42 has only 2 digits, the compiler adds zeros, so output becomes 0042. Third example, string printf percentage point 3 yes hello. Here only the first three characters are displayed. Output becomes HEL. Now let us understand this using a real life example. Suppose your mobile phone battery shows 75%. The phone displays only the required precision. Similarly, when you see your bank balance, it shows rupees 2500.75 and not 2500.75432781 because only two decimal places are required. So precision helps us display data neatly and accurately. Next one is length modifier. Sometimes the normal integer data type is not enough to store very large numbers. In such cases, we use long int. The length modifier is represented by capital I. For example, printf percentage capital I d comma 1 2 3 4 5 6 7 8 9 L. Here capital I tells the compiler that this value is a long integer. Think about storing money. If you have only rupees 100, a small purse is enough. But if you have 10 lakh, you need a bigger bag. Similarly, large numbers require larger data type. You can see that long integers can store larger values than ordinary numbers. Therefore, whenever we expect very large numbers, we should use long int. This slide explains an important difference between width and precision. Many beginners get confused here. Remember this simple rule. Width means how much total space should be reserved. Precision means how many digits should actually be displayed. Now suppose width equal to 3, precision equal to 5. The compiler first satisfies the precision requirement. Then it checks the width. Since 5 digits already exceed 3 spaces, the width is ignored. Now consider another example. Width equal to 8, precision equal to 3. The compiler first creates 3 digits. Then it adds spaces to make the total width 8. So precision controls the number itself. Width controls the surrounding space. Imagine writing an exam. The answer sheet provides 10 lines. This is like width. But the teacher asks you to write at least 5 points. Those 5 points are like precision. One controls the available space, the other controls the required content. This table summarizes everything we have studied so far. Now look at this diagram carefully. The diagram shows the complete structure of a printf statement. A printf statement mainly consists of two parts: a format string, variable list. The format string tells the compiler how the output should be displayed. The variable list contains the actual values that need to be printed. Int age equal to 20, float CGPA equal to 8.75, printf age percentage d comma CGPA percentage 0.2f, then variables age comma CGPA. Here percentage d displays the integer value of age, percentage 0.2f displays the floating point value of CGPA with two decimal places. Think of the format string as a template and the variables as the actual information that fills the templates. Always remember one important rule: the number of format specifiers and the number of variables should match. If they do not match, the output may be incorrect or unpredictable. We have learned how to display output using printf. Now let's learn how to receive input from the user using the scanf function. The word scanf stands for scan formatted. It is a formatted input function used to read data from the keyboard and store it in memory. For example, suppose we are writing a program to calculate a student's total marks. Before calculating the total, the computer must know the student marks. How does the computer get this information? It asks the user to enter the marks. This process is called input. The scanner function performs this task. Unlike printf, which sends data from the computer to the screen, Scanf brings data from the keyboard into the computer. Think of a classroom. When the teacher asks the question, student answers. The teacher is receiving information. Similarly, Scanf receives information from the user. Now let us understand the syntax of Scanf function. Scanf format string, comma address list. It contains two important parts. First part is format string. The format string tells the compiler what type of data the user is going to enter. For example, %t integer, %f float, %c character, %s string. In second part, the address list tells the compiler where to store the entered value in memory. That is why we use address operator ampersand before variable names. Int age scanf percentage d comma ampersand age. Age is the variable, ampersand age means the memory location of age. Imagine you receive a courier. The delivery person needs your house address. If you only tell your name, he cannot deliver the parcel. Similarly, the compiler also needs the address where it should store the data. The ampersand symbol provides that address. Remember this interview question: why do we use ampersand in scanf? Because the compiler needs the memory address of the variable to store the input value. Now let us understand this complete C program. We will explain it line by line. Hash include stdio.h, that includes the standard input output header file. Without this file, the compiler will not recognize printf and scanf. Then end to main, every C program starts execution from the main function. Int a, here we declare an integer variable named a. Then float b, this declares a floating point variable named b. Printf, enter integer and then a float. This means this message is displayed to the user. It tells the user what input is expected. Then scanf %t, %f, ampersand a, comma ampersand b. This is the most important line here. %t means read an integer. %f means read a floating point number. Ampersand a stores the integer. Ampersand b stores the floating point number. Notice that notice that both inputs are read using a single scanf statement. The final statement, printf, you enter %d and %f, comma a, comma b. This displays the values entered the user. Then returns 0 indicates that the program has finished successfully. If I remove the ampersand before a or b, will the program work correctly? No, because the compiler will not know where to store the entered values. Now let us see how the program executes. The program first displays enter integer and then a float. The user enters -3, 3.4. The first value -3 is stored in a variable a. The second value 3.4 is stored in variable b. Finally, printf statement displays you entered -3 and 3.4, 0, 0, 0, 0, 0. You may notice that 6 digits appear after the decimal point. Why? Because by default, the %f format specifier prints 6 digits after the decimal point. If we want only 2 decimal places, we should write %.2f instead of %f. then the output becomes 3.40. This makes the output cleaner and more professional. And today we learned about formatted input and output functions in C programming. References. Thank you everyone. Happy learning, happy coding.